to the cloud. All right. All right, so we are recording, here you go. I'm gonna start with number 12 or 20. Huh? Yeah. Okay, and so if you're ready, did I not give you one?
No,
Thank
thank
you.
you.
All right, if you're ready, number 20. So again, this is being recorded for you. On number 20, we're looking at the rectangular playground. It is telling you that you have a rectangular playground, and it looks like this, and it's being divided by some value. So I'm gonna call this X, X, X. I'm gonna call this Y, and I'm gonna call this Y. So according to the perimeter formula, I've got a 3X plus a 2Y, and that's equal to 624. If I solve for Y, I think I'm gonna do that. I'm gonna solve for Y. Or I can solve for X, it doesn't matter. Let's go with subtracting Y, so that I have 3X is equal to 624 minus 2Y. And now I can divide by 3 all the way across. So now I have X equals 208 minus 2/3 Y. And I can now solve accordingly. So I have X already. I now want to use the area formula, and the area formula is X times Y. So given that, I'm going to substitute in for this. I'm going to now say Y times 208 minus 2/3 X, or 2/3 Y. And if I distribute my Y, I now get 208 Y minus 2/3 Y squared. I'm now going to use the negative B over 2A formula to get X. So that gives me the X value. No, I'm sorry. In this case, it'll be a Y since I have a Y. So I'm going to use negative B over 2A, negative 208 over 2 times negative 2/3. That equals in 208, negative 208 over 1 times, if I do keep change flip. So remember, I'm going to get negative 4/3, so it'll be now 3 over 4. Negative 3 over 4. The negatives will cancel. 4 goes into 208, and then times 3, 156 times. So this answer is 156. So if I now take that value and go into my formula where X equals 208 minus 2/3 times 156, all of this value is 104, all of this part here that I'm squaring off. So my X value is actually 104. Remember, these are Y values. So my Y is 156, my X is 104, and this product will be my maximum area. If you multiply those together, you get 16,224 square feet. Cool. So that's number 20. And again, this is being recorded, so you can always go back and take a look. I'm going to go back to 19. We're going backwards. As you look at number 19, you're given x squared plus 7x minus 12. And so the first thing I'm thinking about is factor. This is actually written as minus less than or equal to negative 12. So I'm going to bring it over as a positive 12. And it will now be less than or equal to positive 0, or just a 0. If I factor this, I get x plus 3, and I get x plus 4, which means my two critical numbers are negative 3, negative 4. So on these questions, I always want to draw a number line. This is negative infinity. This is positive infinity. Here's negative 4. Here's negative 3. And just remember your test points now. I have a 0 here. I like that. I have a negative 5 here. I like that. These are my two test points on the extremes. And I have a test point here, which is negative 3.5. What I want to do is I want to throw these test points into my factors. So, for example, if I start with using these factors, if I start with 0, I have 0 plus 3 times 0 plus 4. Is that less than or equal to 0? And the answer is no, because I need a negative. I guarantee you that if I use the negative 5, negative 5 plus 3, and negative 5 plus 4, that is also not going to result in something less than 0, because it's positive. So those are two no's. So that means that likely this will be negative 3.5 plus 3. So this gives me a negative answer. And negative 3.5 plus 4, this gives me a positive answer. This will definitely be less than or equal to 0. So that's a yes. So my only solution interval in this case is that one. When you do the work in an extended response like this one, make sure that you show the factor. Make sure that you show the number line. Make sure that you show the test points. Test the points and show the test points. You have to show all this to get all values, all possible answers correct, the whole possible answer correct. These each are parts of a question. If you miss a part, I have to take away the point. I may not even be the one grading it. Okay, because we're back to that ridiculous you grade my paper thing. It's a long story. Okay, so that's 19. Let's look at 18. Number 18 is actually very simple, and I want you to remember this. They give you negative x plus 8 divided by x minus 2, and that is greater than or equal to 0. Whenever you have this type of question, please, you're going to say negative x plus 8 equal to 0, and you're going to say x minus 2 is equal to 0. So in this one, obviously x is equal to positive 2, so that's one of your cutoffs. On this one, I believe you get negative x is equal to negative 8, right? Because you subtracted 8 and you cancel the negatives. So x equals 8. So now we're looking for a positive answer. This is a positive that we want for the equation. So you draw your number line, negative infinity, positive infinity, you have cutoffs. You have a cutoff of 2. You have a cutoff of 8. And so now that you did that, now let's use some test points. So here's the test point I'm liking. I definitely like 0. I definitely would just choose a 3, and I would definitely just choose a 9. So in this equation, if they're looking for this to be true, what you want to do is plug it into the original question. So this is minus some number plus 8 over some number minus 2. And there's a reason I'm writing it like that. This makes it easier to see. So for example, if I try the 0, put a 0 here and a 0 here, I get 8 over negative 2, which is a negative number. So this is not a solution, right? Easy to see. Do the same thing. Now let's put in the 3. If I put a 3 here, that's a positive 1. And that's going to be a positive 5. So this meets criteria. So this is definitely one of my solutions. I am going to say in this case, it cannot be 2, but it can definitely be 8. So make sure that you use the 0, not the infinity, but the interval of 2 not inclusive and 8 inclusive. Because the 2, because of the denominator issue, right? That's why we cannot have 2. And then I need not try the 9, but if you want to, let's do the 9 just for the sake of negative 9 plus 8 divided by 9 minus 2. That's going to give me negative 1 at the top over some positive, in this case 7. That's a negative number, so this does not meet the criteria. Again, because I want a positive here. Okay? Next number is 17. In 17, we have a solve the system by the addition method. So if you notice, I have 3x plus 7y is equal to negative 31. This is 5x minus 4y is equal to 11. So I don't know about you. I like the x's. I'm going to cancel those guys out. So I'm going to multiply either one by the opposite sign. So I'm going to go with negative 3 down here. You can choose negative 5 instead. That's fine too. So if I distribute the 5, I'm getting 15x plus 35y is equal to negative 155. And if I distribute the negative 3, I get negative 15x, which I want because I want it to cancel, plus 12y. And this is equal to negative 33. That's okay. So these guys cancel, and I end up with 47y is equal to negative 188. Divide by 47 on both sides. I'm getting y is equal to negative 4. If y is negative 4, then I'm going to take the 3x plus 7y equal to negative 31, and I'm going to substitute in for the y the negative 4. So this will become 7 times the negative 4. So now I have basically 3x minus 28 is equal to negative 3. If I add 28 to both sides, I'm left with 3x is equal to, I think I have a boo-boo. I have a boo-boo. This is not a 3, right? This is a 1. 31, that's why. So this is equal to -3, so therefore x is equal to -1. So this solution should be -1, -4. Okay, so that's number 17. Going backwards, let's look at 16. So 16 goes back to the compounded interest. So we have compounded interest versus continuous. If you look at this carefully, compounded interest, that is the A equals P times 1 plus R over N, and this is raised to the NT, versus the PERT, which is A equals, so A equals P, the principal amount, times E raised to the RT. Now, in number 16, they're not even asking you for PERT, because technically they're asking you both compounded interest. They're telling you the p-value is 10,000. They're telling you the time is 9 years. They're telling you that this is 5.4% for one interest. So the rate, you're going to change to 0.054, divided by 100, basically. And this is the same. This is 10,000, 9 years, but this is 0.055. What changes in the two investments is that one of them is monthly, the other one is quarterly. So make sure you can do these in your calculator. If they don't even ask you for PERT, but know that they could, if they say the word continuous compounding. If you see continuous, what are you going to do? PERT. Continuous PERT. Okay? Please don't forget. So in our example, this would be 10,000, parentheses 1 plus 0.054 divided by 12, and this is raised to the 12 times 9. You repeat the process over here. This one is 10,000 times 1 plus 0.055 divided by 4, and this is raised to the 4 times 9. Now, if you follow my marker, for those of you that still have issues with order of operations, look, you're going to do this part first. Then after you do this part, you're going to do this part second. You're going to add the 1. And when you're done with that, so this is like 1, this is like 2, and this is like part 3, you're going to multiply that, find out what that is, and you're going to raise all of this to that number. Then part 4, or the last part, is you multiply by 10,000. So one more time, you would do part 1, part 2, part 3, and the last part you do is multiply by 10,000. So you're going to go 1, 2, 3, and then after you get all of this, then you multiply by 10,000. So this is like 4. Okay? Now what do you get for each respectively? I forget. For the first one? Yeah. What'd you get? 10,045? I'm not getting that. I'm not, these are not, what did we get last time when we did this? So I don't think that's correct. Can somebody verify another number? 6,000, 16,000, 240.28, okay. And the other one? 16,349 and change? 75? So which is a better investment? More money, right? More money wins. Okay, so that was number 16. The answer would be C for you, yes. Okay, number 15. Let's look at 15 real quick. And the rest is already recorded, so I'm not worried terribly, but I'll record it anyway, going backwards. So they gave you this f of x, and they tell you that this is y sub 0. Y sub 0 means initial investment or initial time period. This is e raised to the 22%, so they already did 0.022. And then the years t right here. So if we take the question and answer it, which is how many will there be in year 2005, assuming 1999 was the initial. So if I take 2005 and take away 1,999, I get what value? I got 6. I don't know about you. So that means that you have e raised to the 0.022 times 6, but then you have to multiply it times the 6,365,000 people. And once you do this, you should end up with 7,260,000. And that should be your answer. This represents the 22% that they're talking about. This represents the initial 1999 start. This is obviously your natural base, and this is obviously the number of years since 1999. Okay, I do want to do 13 and 14 real quick. So let's do 14 and 13. So this time I'm going to throw you off a little bit. I'm going to go back to 13. And I want you to listen, please. You see how this says y equals 25 minus 6x? I don't like that format. I'm going to add the 6x to both sides so that it reads 6x plus y equals 25. That's how it should look. That's how you want it to look. Here you have the original 6x plus y equals 31. This is already given to you. So if I subtract one from the other, so if I multiply all of this by -1, I get negative 6x, negative y, negative 31. So that cancels and that cancels, and I end up with a big old 0 equal to some number, negative, in this case, -6. Is that logically possible? No way. This is a big old null set. That is a no solution. This means that these are parallel lines. So that if you're looking at the system, this is actually parallel lines. Okay. Number 14. I'm going to do number 14 down here. These are related cousins. What I want you to notice in number 14 is that they give you 3x plus y equals 11. They give you 9x plus 3y and that's equal to 33. So how do I solve for one of the variables? I have to multiply by 3, right? At least. So let's go with -3. So that's going to become -9x minus 3y equals -33. And I want you to stop and listen, 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 listen. Is it not true that 0 equals 0? Is that a true statement? It is true. This is a true statement. So technically, in theory, this is the same line. This has infinitely many solutions. But apparently I'm writing like a psychopath. So infinitely many solutions. And that means that you end up with some number xy is in the set of numbers of 3x plus y equals to the solution, or pay attention to this part, you could also have the x comma y, where numbers in this solution also can be 9x plus 3y equal to 33. All right, so that is also possible. So that's what the answers will look like respectively in the two weirdos, meaning you don't have one solution, but you have either infinitely a ton of solutions or no. So that's 13, 14. Let's talk about number 12. We have time. Let's talk about number 12. Actually, let me get a new page because it starts to look weird. Okay, so in this number 12, you have 2x over x plus 6. And according to this, this is less than x. Whenever you see this, what I want you to do is move this guy. So you have 2x over x plus 6. And you're going to subtract the x over 1. And set that less than 0. Does that make sense? The next step is you have to multiply to get a common denominator. So I need an x plus 6 over here, and I need an x plus 6 over here. Now, the reason I do that is I need a common denominator, which I have now. So my new solution is 2x minus x squared minus 6x, and all of this is over x plus 6. And this has to be less than 0. Now, if I combine the like terms, you notice this gives you -4x minus x squared. And this is all over x plus 6. So far, so good. And now we solve. Remember, you set this to 0. You set this to 0. That means that x cannot equal -6. Up here, if I take out x, I end up with x, I'm sorry, -x. If I take out -x, I end up with x. I suck. Give me a minute. I end up with 4, and then this will be plus x. Does that make sense? That's -4x, -x squared. So I have a repeating 0, and I have a -4 up here that x cannot be. And here x cannot be -6. So that means here's my number line. Back to that number line thing. -infinity to infinity. Here's -6. Here's -4. Here's 0. So my test points. Let's play test point. For my test points, I'm going to try, let's go with -7. Let's go with -5. Let's go with -1. be simple and 1. And now plug them in. If I'm plugging it in, I did this a couple of ways. One of the ways that I actually did it was I took the original 2x over x plus 6 and I didn't manipulate it. I left it just like this. I'm not necessarily a fan of this, but it works. So for example, -7. So 2 times -7 over -7 plus 6. Is that less than -7? Notice that the 7 is what I'm looking at. I'll do that again. Let's do that again and let's repeat the process. This time I'm going to use -5. So that means 2 times -5 over -5 plus 6. Is that less than my -5? Do the same with the -1. So is 2 times -1 over -1 plus 6? Is that less than -1? And I'll do the same thing with +1. So 2 times +1 over +1 plus 6. Is that less than 1? I end up with 2 intervals that work. If you notice, the -5 works. The -5 does work, and so does the 1. So both of these work. So that means that negative or 0 to infinity is one answer, and the other answer is -6 to -4. And that's just mental math. So that's number 12. These don't work. If you notice, you get -14. This is over -14 over 1. That's a positive. So that is huge compared to -7. So that doesn't work. And this one gives you -2 over a positive 6. And that is not less than -1. So that doesn't work either. That's number 12. All right, let's do number 11. Huh? Yes, should be C for that one. Okay. I'm gonna hop over to number 1. And I will tell you that this is recorded for you all the way through, so you're not gonna miss out on anything. I just want to go this way. Okay, so for number 1, going back to the basics, they're asking you for the coordinates of the vertex. Please remember, -b over 2a is your friend. The f of -b over 2a, which basically means substitute that back in, is your answer for the y. In our example, they give you f of x is equal to -3x squared plus 6x plus 1. If I use -b over 2a, I get -6 over 2 times -3, which tells me x is 1. So x is equal to 1. Look at your answer choices. How many 1s do you see for x? Only 1, which is answer choice D. Let's say they did give you that luxury. You're going to take -3 times 1 squared plus 6 times 1 plus 1. So this is going to give you -3 plus 6 plus 1. Answer is +4. So your answer choice, or for the vertex here, if you had to work out the whole thing, is 1, 4. Okay. Number two. Number two is asking you to find the axis of symmetry. Axis of symmetry is x equals negative b over 2a. What they did differently here is they're writing this equation with the vertical shift in front, and then they're giving you a negative x plus 5 squared just to throw you off. That's all they're trying to do. So remember, this is plus 4. All of this can be moved simply over here. So this is negative a, which is negative 1, x plus 5 squared plus 4. It's that simple. And if you remember, this guy is always a hypocrite. So that's going to be negative 5, comma 4 is the vertex, which means that the axis of symmetry is where x equals negative 5, which I believe for you is answer choice A. Cool? All right. Number 3. On question number 3, they are asking you for the range. So find the a vertex. Find the vertex. The vertex will give you the y value. They're giving you f of x is equal to negative 3x squared plus 3x. So again, we're going to use negative b over 2a to find the x. And once I find the x, I'm going to throw it back in and find y. And y will tell me the range. Remember that there is a difference between minimum and maximum. If a is positive, this is a minimum. If a is negative, this is a maximum. In this case, what do you notice? A is negative, so it's a maximum. So in this case, that means that this is coming from infinity, negative infinity, up. So that'll be negative infinity, comma, and then when you work this out, you are going to get 3 over 4. But let me show you how. So negative b over 2a, negative 3 over 2 times negative 3. Ends up being negative 3 over negative 6, which is 3 over 6, which is 1/2. That is your x. To find the y, you're going to take negative 3 times 1/2 squared plus 3 times 1/2. So this gives me negative 3 over 4 plus 3 over 2. However, before I add these, I have to build that denominator up by multiplying by 2 over 2 on either side. This all becomes 6 over 4. Negative 3 plus 6 is positive 3 over 4, hence where I'm getting this 3/4 from. So whatever this is, remember, it's a max because that's negative. And that means that it's sad face, sad parabola. Okay, number 4. You want the x-intercepts. To get x-intercepts, y is 0. So that means that this negative x squared plus 17x minus 72 is equal to 0. But there is no way I can do this until I get rid of this negative. So take the whole thing, multiply by negative 1. This makes this positive x squared minus 17x, and this makes this positive 72. And it's still equal to 0 because I can multiply $1 million times 0 and you still have 0, right? So now I can factor. And in factoring, I notice that if I have x minus 8, x minus 9 equal to 0, then my solutions are x equals 8 and x equals 9. Intercept-wise, for the x, this is an 8, 0, this is a 9, 0. That's what they represent. And that is your answer, C. Okay, question number 5. On 5, it's another one where they just wrote it weird. They wrote y plus 9, and that is equal to x plus 3, and that is squared. The only thing you need to do here is if you want to find the y-intercept is where x is 0, number 1. Number 2, subtract the 9 on both sides. So if I subtract 9 here and I subtract 9 here, I also will be able to solve for y equals 0 plus 3 squared minus 9, which tells me y is equal to 0. So this answer choice has to be 0, 0. Number 6. They're asking you for a minimum. If they're asking you for a minimum in your mind, I need you to start doing this and understand that that point that they're giving you is -6 and where x is -1. So this is 1, -6, which is telling me that the range, domain and range. So first of all, the domain for any quadratic, oh my God, that's horrible handwriting. Hang on. The domain is always -infinity to infinity unless you're told that it's restricted. This is not restricted. The range, because you know that this is a minimum, we know that this has to come from the bottom up, which is -6, inclusive to positive infinity. Please listen to this. If we're talking about the range, we're coming this way. Home under range, from the bottom up, always. Okay? Okay. Number 7. Doing good on time. Number 7. They're asking you whether or not it's a maximum or a min. So first of all, we're looking at f of x. And this happens to be 2x squared minus 4x. Now that a is positive. If a is positive, this guy is going this way. And that's my point. And therefore, that point is a minimum. So look at your answer choices immediately. And which one are you going to get rid of? I'm going to get rid of A and D. Bye-bye. Now I want to solve for -b over 2a. So -b over 2a, that gives me 4 over 4, which is 1. I already have the answer, but if you don't see why I'm saying that, ask yourself again. Look at the answer choices. We know it's a minimum, so eliminate A and D. Now look at B and C. Why did I say I already have the answer?
Only one positive one.
Only one positive one. Between C and B, look at B and C as answers. B and C. Look at the answer choices. Yes, they're both minimums. So yes to that. But it looks like B is +1, comma, some number, -2. They're both -2, actually. And C is -1, -2. So I already have the answer. It's B. Plug it in if worst case, you can solve it anyway. All right, number 8. Yay, plenty of time. And I have these recorded anyway, even if we run out of time. Here's number 8. Number 8, they gave you a favor. They said, here's x plus 4 in factor form. Here's x plus 3 in factor form. Here's x minus 7 in factor form. And we want this to be a positive number. This is a positive, right? Greater than 0 is positive, right? My solutions, -4, -3, +7. So I draw my number line. Here's negative infinity. Here's positive infinity. Here's -4. Here's -3. Here's +7. So let's get some test points going. I love 0 test point. We're going to try the 8 test point. We're going to try -5 test point. And we're going to try a -3.5 test point. So when we do the math here, there's also a test point, by the way. So -5 plus 4 times -5 plus 3 times -5 minus 7, is that a value that is positive? Let's see. This is -1. This is -2. And this is -12. I would argue no. Because as a product, you get a negative number. Okay, what about -3.5? -3.5 plus 4. -3.5 plus 3. And times -3.5 minus 7. Is that a value greater than 0? And yes, this is. So this is a winner chicken dinner right now. So if you notice, I'm putting parentheses there. I'll do the same thing with 0. So 0 is easy. 0 is going to leave me 4 times 3 times -7. And that is a negative number. So this is a no. Okay, and now we try the 8. Well, 8 plus 4, that's positive. That's good. We have an 8 plus 3, that's positive. That's good. And we have an 8 minus 7, that's positive. That's good. So this is a yes also. So my other interval is over here. It's this and this. So I believe for you, that is C. Okay. We're almost done. Number 9. On question 9, you have a perfect example of factor by grouping. Same thing here. You have 16x cubed plus 48x squared minus 25x minus 75. Is that a number that's greater than 0? When I do factor by grouping, I'm going to take 16x squared. And that's going to give me an x plus 3 in here. I'm going to go with a minus 25. And here's an x plus 3 in here. And that has to be greater than 0. So I get a perfect square, 16x squared minus 25. And I get an x plus 3. So what I'm going to do now is this is 4x minus 5 times 4x plus 5 times x plus 3. And that has to be greater than 0. That means that x cannot be, but we're going to test the intervals of 5/4, -5/4, and -3. So those will be our cutoffs. Again, negative infinity, positive infinity. So here's -3. Here's -1 1/4, which is -5/4. And here is +1 5/4. I like the 0 again as a test point. So I'm going to go with test point of 0. I'm going to select a -2 in here. I'm going to select -4 in here. These are my test points. Over here, I'm going to select the +2. That's a test point. Same process. I'll give you the answer. After you test your points, you're going to go in here. and you can toss them like 4 times -4, for example, -5 times 4 times -4 plus 5 and times 4 -4 plus 3 and see, is that a number greater than 0? I believe this is a no. So this is a no. Repeat the process. We do 4 times -2 minus 5 times 4 times -2 plus 5 times -2 plus 3 this is a yes. So this is an interval that's worth keeping. The 0 is very easy. 4 times 0, this gives you -5 times +5 times 3. And this actually is a no. And do the same thing with the +2. So you're going to go with 4 times 2 minus 5. 4 times 2 plus 5. And 2 plus 3. And this is a yes. So this is an interval worth keeping. All right, and so I believe that's B for you, B as in boy. The other two are also recorded slowly. You can take your time listening to that. I'm going to pause this recording here and stop the share. So you have 2 recordings waiting for you.